True or false? In a series circuit, the current leaving the cell is greater than the current entering it. This is not true. This is false because the main current that leaves the positive terminal of the battery comes in the same amount or enters in the same amount the negative terminal of the battery. So you have to write it correctly. False, in a series circuit, the current leaving the cell is equal to the current entering it. B. Two different lamps L1 and L2 are connected in parallel in a circuit. By different lamps we mean that they have different rated voltages. The voltage across L1 is different from the voltage across L2. So this is false. Two different lamps L1 and L2 are connected in parallel in a circuit. The voltage across L1 is equal to the voltage across L2 due to the law of uniqueness of voltage in parallel grouping. So regardless whether the lamps are identical or not, if they are connected in parallel, then they certainly have the same voltage across their terminals. C. To measure the current in a lamp, we connect an ammeter in parallel with the lamp. So this is not the truth. If we do so, an error will be indicated on the ammeter and fire may take place because this is a short circuit. Ammeter has low resistance, so if you connect it in parallel, this would be short circuit, allowing the flow of high intensity current. That's why we shall connect the ammeter in series, not in parallel. So false, to measure the current in a lamp, we connect an ammeter in series with the lamp. Two lamps are in series D now. Two lamps are in series if one of them is connected next to the other in succession. True. In a series circuit, if one lamp burns out, the light of the other lamps go out. So a burnt lamp acts like an open switch. And as you can see in this figure, if one of the lamps is burnt out, it acts like an open switch and cuts off the circuit. So now no current passes through the second lamp and thus it turns off. It doesn't burn, it only turns off. 3. Choose the correct answer. In a 4.5 volt cell, there are 3 dry cells of 1.5 volt each that are grouped in series in opposition, or one of them is in opposition with the other two. So we have to try here and guess. So it seems that 4.5 is triple 1.5, or in other words, it's 1.5 plus 1.5 plus 1.5. So we expect it to be in series aiding. Here in the book they mention series. When they say so series alone, they mean series aiding. When they mention opposition, they mean series opposition. Anyway, if we now draw the 3 batteries such that the negative terminal of one is connected to the positive terminal of the other, negative connected to the positive, so, or in this way, we have negative connected to positive, negative connected to positive. We know that in series aiding, U equivalent of series aiding grouped batteries is equal to the sum of the voltages, so it's 4.5. So these 3 could be replaced by one battery whose voltage is 4.5. A 1.5 volt dry cell is in opposition with 2 other dry cells identical to it. The resulting voltage of the grouping is 3 volt, 4.5 volt, and 1.5 volt. So this is the representation of the given here, having 2 dry cells in series aiding while the other in opposition. Both dry cells here tend to drive the current anti-clockwise to the left, while the other one here in opposition tends to drive the current in the opposite direction, clockwise. So we add the voltages of those that are aiding. 1.5 plus 1.5 is 3. Then we subtract the opposing one, minus 1.5, so this is equal to 1.5 volts. So the correct answer is C. Now, the 3 lamps L1, L2, and L3 are identical and carry an indication of 6 volt. They are connected to a 12 volt battery as shown in the figure below. The voltage across L1 is 5 volt. So carrying an indication of 6 volt doesn't mean that they're going to get 6 volt in the circuit, and being identical doesn't mean that the voltage of the 3 lamps will be the same in the circuit. It all means that they need the same voltage to function normally. Now we're given that L1 in this circuit, the voltage across L1 in this circuit is 5 volt. So calculate the voltage across L2 and L3. We have that U battery is U1 plus U23 grouping. By 2, 3, I don't mean U of 2 plus U of 3. I mean this is a notation just to name the grouping including 2 and 3, L2 and L3. So as a whole grouping, this grouping is in series with L1. That's why we add the voltage and it's equal to the battery. Voltage across the battery. So by law of addition of voltage in series grouping, 12 equal to 5 plus U to 3 grouping. U to 3 is 12 minus 5. This is 7 volt. Now describe the brightness of each of the 3 lamps. In order to describe the brightness of the lamps, we need to find U2, U3. So far in this part, we are not done. It's not enough to find the voltage of the grouping. We have to find the voltage of each component in this grouping, which means we have to find U2 and U3. How are L2 and L3 connected to each other? They are connected in parallel. That's why U of the grouping, including L2 and L3, is equal to U2 equals U3 equals 7 volts by law of addition of uniqueness of voltage in parallel grouping. Alright, so now we have to compare the voltages of the lamps to the rated voltage. As for U1, which is 5 volt, it's less than the U rated, which is 6 volts. That's why L1 glows weakly. However, U2 equal U3 equals 7 volt, greater than U rated, which is 6 volts. Then L2 and L3 glow brightly and may burn out.